Formula One is perhaps the highest level of international motorsport. It's about getting the lightest car for the best performance. We really are chasing grams. Typically that means falling towards composites because composites are such a sort of key benefit in that overall lightweighting strategy. The problem with working with composites is they're very, very difficult. You're working with fabrics, you're working with things that it's hard to quantify exactly how you make something out of these individual pieces of fabric that then somehow become something super strong on a race car. So it's a very, very difficult process to quantify from a design viewpoint that you can have control over in a hand laminating environment. So really we needed to look at how do you take the perfectionist of F1 to the next level where you can really control, quantify, manage those designs much more accurately and repeatably. For us, Siemens Fibersim is a piece of software that oversees all of the different departments, so you can suddenly get rid of all the ambiguity, all the things that the hand-skilled guys just did, but we don't quite know what that was. Starting to work with Fibersim was a long-term project to really revolutionise and revisit everything we did with composites. The biggest composite part we do is the race car chassis. Over 1,000 plies of composites material, and it's the most critical in terms of crash worthiness in protecting the driver in a survival for all heavy impact circumstances. So that to us is the biggest, most complicated challenge. Taking the Fibersim software and helping us for the first time quantify, understand and repeatably make the race car chassis was a very, very big programme for us. Being part of a Formula One race team, it's all about the urgency of everything you do. We're not only looking for the ultimate car speed, it's how do you engineer those parts faster so you can bring performance upgrades to the track in a more timely manner. When you're looking to gain thousandths or tenths of a second in performance, the more minor upgrades you can bring to every event, the bigger the overall gains become. Using Fibersim to help define a 3D model that's accessible in design, accessible to manufacturing, really helps empower all of the people involved to make much better, much more precisely controlled composite parts. The typical lead time for composite parts might be a few weeks, but how can you turn around the parts in that timescale, re-engineer, manufacture, ship to a track halfway around the world in just a few days? So what we look to do is make our processes more and more efficient. The Fibersim software helps better control those processes so we can do iterations or evolutions of a part much more quickly. We've really started the whole design process again, going back to the concepts of what composites design are, taking the Fibersim tool and implementing it across all of our composite design parts from the most simple to the most complicated. The biggest advantage of using Fibersim in a controlled design environment is the consistency and confidence it brings to everything we do. You go back to the non-Fibersim driven methods, everything was approximate, it was good enough. Implementing Fibersim for us is all about having that absolute confidence in every part that we design and manufacture and put on the race car. We've worked with Siemens for many years now and they're one of our high-level technical partners. We can share everything we do to really push that competitive advantage of what a technical partner can bring to a team. So it's a great two-way partnership. Fibersim for us is the best integrated tool. It integrates into our native CAD systems, our manufacturing systems. It's the way that Siemens gives such open architecture to link into everything that we've already got into the factory. The Fibersim model gives you a single solution that everyone can understand and share. It just works.